In the following section, we will demonstrate on a brief example programmed in ladder the language functions described above and how they are supported by the powerful program editor. Our plant comprises two identically designed pumps that need to be controlled. For this purpose, we will develop a reusable function that can be used several times over in the program. All necessary signals are routed to block parameters, which will be assigned pump-specific variables when the block is called. We want to equip our program with the following functions: switching the pump motor on and off by means of a block, recording and display of the pump operating hours, symbolic addressing. We will now show you step by step how the blocks are developed and how the program is integrated into the CPU execution cycle. To do so, we have to enter the symbols, create the block, generate the user program, and load and test the block. In our case, a project has already been created in the CPU by means of the Simatic Manager. First of all, we enter the symbolic addresses of the global variables. To do so, we double-click the symbol table to open it. The symbol table contains, among other things, all inputs and outputs required to control the two pumps. After editing the symbols of the global variables, we need to create the new function in our project. In our case, this is function FC2, which will contain the user program of the pump. A properties window opens automatically. We enter in it a symbolic name for the new block and add a symbol comment. After the properties window has closed, the block is stored in the project's block container for further processing. The actual program development starts by opening the newly added block. This action starts the program editor. Since we want to create the pump block as a multiple call function, we first have to specify the block interface by means of the variable declaration table. In our case, the interface is composed of 5 input and 5 output parameters. The symbolic names assigned here to the block parameters will be used later for generating the program. They make the code easily readable and provide, as required in our case, the possibility of multiple calls. Now we start to actually develop the program within the block. You are assisted in this task by the Program Element Catalog, from which all functions required for program development can be placed in the program development area by drag and drop. In our case, we have completed the first network in which part of the pump block logic is stored. The subroutine is easier to read if you assign a network title and a comment. In a second network of the pump block, the required operating counter function is created. We use for this the system function SFC101, which is contained in the standard library that comes with the project. This function is now also available to the programmer in the Program Element Catalog, and can also be placed in the network by drag and drop. Next, we assign variables to the inputs and outputs of the function. Programming the pump block is now completed. We now save the block. For the pump block to be able to control both pumps later on, it must be called once for each pump in organization block OB1. We open OB1 and place the pump block in 2 networks by drag and drop. The block interface is assigned the variables of the first pump. Symbolic addressing can be used for this. We create the second network containing the control of the second pump in the same way as the first, using the inputs and outputs for the second pump. After saving the pump block and its associated organization block offline in the project, the last step is to load the newly generated program into the CPU's user memory. To do so, we highlight the blocks and call the operating function in the menu bar of the Simatic Manager. After loading the blocks into the CPU, we can go online with the same editor to have a look at the status of the pump block. We have shown you in this module that the three standard conforming programming languages, ladder, function block diagram, and statement list, due to their large inventory of commands, their easily learnable programming structure, and the Windows conforming, intuitively operable program editor, are powerful tools, both for newcomers and for experienced programmers, which allow you to save time and costs during the implementation phase.